Hello, this is Zilal.
Hi, this is Payel.
This is reproducing heartful words, quantifying biases in clinical contextual word embeddings. The general problem is deep embedding models such as BERT, which trained on real-world medical notes from Mimic3, may encode social biases, leading to unfair model behaviors across groups defined by gender, language, ethnicity, and insurance status. Eventually poses bias and favors one group over other. The specific approach taken in the paper, we use the paper pre-trained models, CyBERT, baseline clinical BERT, and adversarial debiased clinical BERT to quantify bias based on how it fills in the blank, missing gender information. Second, evaluated the models by calculating fairness metrics and comparing performance gaps on 25 downstream tasks. The pre-trained models are biased via both the log probability bias score and performance metrics evaluation. This is the original results in the above, and this is our reproduced result. The bias score, if it is positive, it means that the model favors male-associated words in that context, and the negative bias score suggests a female bias. Based on Wilcoxon test, the same results from the paper we had, where 7 out of 8 categories have a significant difference in baseline clinical BERT, whereas in CyBERT, 4 out of 8 have a significant difference.
We also evaluated our datasets using both the pre-trained clinical baseline model and the adversarial gender debiased models. And in both cases, we've seen classifiers trained with these models showed multi-group fairness performance gaps across gender, language spoken, ethnicity, and insurance status. We counted the number of downstream classification tasks with a statistically significant difference, as well as the percentage of significant tasks which favor a subgroup. The top two charts are the reproduced ones, and the bottom chart is from the original paper, and all of them show us the similar trend that is the bias exists and is favoring a particular subgroup. On the right hand side, we see two tables which again from the original paper and the reproduced one, but each one of them is comparing the baseline and the debiased, and both show that although debiased, the debiasing does not greatly reduce the number of statistically significant gaps. We also tried fine-tuning the baseline model, and coming up with the same chart, but we don't see much difference. This trend is the similar. Now, as we already talked about the trend being similar between the reproduced version and the original paper, the magnitude of the tables could be different, and that could be due to several factors. Like slight differences in how notes were tokenized, aggregated, or filtered could be one of the reasons. Even if the same architecture was used, different random seeds or training epochs could lead to variation in learned representations. We used a smaller set of data, so small subgroup sizes might have led to higher variance in performance estimates. And especially in the performance evaluation side, we tried only on 25 tasks instead of 57 from the original paper, so that could also have led to the difference in magnitude. Next, as an extension to the reproducibility scope, we have calculated the same performance gaps across intersectional demographic subgroups, that is gender and ethnicity. So we have two groups here, group 1 and group 2. Each one of them is a combination of gender and ethnicity. And here it's shown that the group 1 is the one that is favored over group 2. So in all the charts across and whatever experiments we have done so far, we have proved the fact and hypothesis of the paper that contextual word embedding models, specifically BERT, indeed create bias. And that is what was the main problem statement of the paper. And that is what we have tried to prove here. Thank you.
Thank you.